C, that would be good to do here first as well. Anybody? Yeah. Okay. Okay, y equals log base, what base is that? 10. All over tangent. All right, now, one of the things I was going to comment, if you're trying to check your answers, or if you're trying to check something on your calculator, you probably figured out already you cannot do this on your calculator. You can't type it like that. Okay, you got to type it sine of x quantity squared, which is what it really is. Okay, and then the calculator doesn't accept that kind of shorthand notation for sine squared. So if you didn't know that already. Okay, so we start with derivative at the top. Now again, a lot of times what I like to do on a big quotient rule one is I like to do that right there so I don't forget about that bottom. Matter of fact, maybe you just put that down there first, right? Maybe you just put that down there so you don't forget about it. It's a thought. So now we're going to do the top. So derivative of the top. So we're going to bring that 3 down. We're going to leave the inside alone. Okay, log base 10 squared, right? So derivative of the outside. Step 1, leave the inside alone. Step 2, times the derivative of the inside, which is 1 over x, times 1 over ln 10. Right? And all of those, well, really 4 things. Those are 4 things all multiplied together. Times what? The bottom left alone. So it's easy to forget that too. You got so much going on there. I mean, that right there is our u prime v. And then we got u minus uv prime. So that's a lot of stuff right there. None of it really goes together. I mean, and you got a fraction inside of a fraction, but I'm not going to make you mess with that. I'm not going to make you get rid of that. Your calculator will. So obviously you'll have some things. But that, the tangent I could put on top and the log and the 3 and the x ln 10. So I can have kind of a fraction here on top of this fraction if I wanted to. Now I got my minus, and now I got the rest of it. So I got u, which is just the top. So that would be log base 10 of x all cubed. And then derivative of tangent is secant squared. And that's really all I can do. I can't really do anything to that, right? I mean, so that's it. As messy as that looks, it's really a pretty straightforward. I'm looking here. The only thing, you see a log, and so could I factor out a log? Sure, if there was log on the bottom, right? But there's not. And there would have been if this would have been flipped. So that is one thing. If this would have been flipped here like this, right, then I'd have had these logs down here on the bottom. And then when I did my thing here, I'd have had, when I left the log alone and then I didn't leave the log alone, I would have a log cubed and a log squared still. I would pull one of those out or some of those out. I could do that. So if this problem had been flipped, right, it'd have been derivative of the top, secant squared, with the bottom left alone. So these two would have just been flipped, right? So this would have been log 10 of x all cubed, and then minus, and now this would have been the top left alone, tangent, and then I had derivative of the bottom. So I'd have had all this stuff. So I'd have 3 log base 10 of x squared times 1 over x times 1 over ln 10, right? And so I'd have had all that, and then I had all this. I'd have had log base 10 of x cubed and then squared. What's cubed and squared? To the 6th power. So see how we'd have had that? I don't think I forgot anything. Okay. So so if this was flipped, then what happens is you just got these flipped on top, but then your bottom is different. Now what could we simplify there? We could pull out how many logs? We could pull out 2 of the logs. Right, so we could pull out log base 10 of x quantity squared, which would drop this to just 1. This would be gone completely. And then what would be down here? That would be to the 4. See that? So sometimes, depending on what you can simplify, depends on how that worked there. So there you had some things in there. So that's one thing you probably want to look at. Two things you probably want to look at in your quotient group. You got your U prime V parts. You got this part here. You're looking to see if anything can go together. Like if I got a 3 here and a 2 over here, I can make a 6 with. Okay, you're looking at that. Then you're looking at this one, see if anything goes together in here. And then you're looking at this and this. You're looking at this and this. You're saying, can I pull anything out? Can I pull anything out that would then cancel this with the bottom? Okay, doesn't always happen. So on the top one, really, we couldn't do anything. But if it was there, we could. Okay, so something to keep in mind. Okay, good one, James. Thank you. What else?
I did one on mine that was square root of x over sine x times 3 to the x.
Sine x times 3 to the x. Okay, there's a good one too. You just got a kind of combo of product quotient. So let's look at that. So of course that's x to the 1/2. So derivative of the top, 1/2 x to the negative 1/2 times the bottom left alone. I don't really need it in parentheses because it's multiplied, but putting it in parentheses to at least to start with wouldn't hurt. But that's derivative of the top, bottom left alone, minus top left alone, now derivative of the bottom. So here's where we need a big old set of parentheses. So we're doing u prime v minus uv prime, and right here when we do the v prime, that's this part, and that's kind of a mess because it's product rule. It's going to have a plus sign in it. So now I'm only focused on the blue down here, and I'm just doing that. Okay, so now I put it in, it's got its own set of parentheses to go. Okay, so derivative of the first sign is cosine, leave the 3 to the x alone, plus sine left alone, and now I'm doing the derivative of 3 to the x, which is 3 to the x ln 3. Okay, right? 3 to the x ln 3, and if there was something inside with that x, I'd have to kick that out there too. But I think, now, see, this would be a class one. I didn't do the fraction part there, right? This is a quotient rule I'm doing. And this would be real easy to just quit right there. I was about ready to. But it's all of this, and then it's the bottom square. So it's sine of x times 3 to the x, and then all squared. Okay? So, like I was just saying, so now we look at it and we say, okay, right here, is there anything I can put together? Well, there really isn't. Right here, I got these things multiplied. Can I combine something? Or multiply something that doesn't look like it? Here, what could I do? Could I distribute? Maybe. But I'm not sure it would do much for me. There's only one little thing I could see that I could simplify. This would be a tough one, right? I mean, again, kind of some easy, some medium, some hard. At some point, I got to decide what are the hard ones going to look like, right? We tend to focus a lot in here when you guys ask me on the hard ones. It makes it seem like the whole test is going to be this hard. It's not. But there is one thing that could cancel out of there. The 3 to the x, right? Because right here, so I could either distribute this, right, and have this and then 2 other sets of terms here. They would all have a 3 to the x in them. And I have a 3 to the x down here. I actually have 2 of them, right? Because this is like sine x 3 to the x, sine x 3 to the x. So I've actually got a couple there. So I could take a 3 to the x out of the top. You get rid of this one. I probably could just leave this the way it is without distributing. I could pull a 3 to the x out of here, right? So I'd have a 3 to the x here, 3 to the x here. I could pull that out. I could get rid of one of these. Okay? So it would end up, so I don't just take time to write all of it. It would end up, this would be gone. That would be gone, and that would be gone, because I would pull that out of this parenthesis, and then I would pull 3 to the x of these, and I'd cancel with one of these. So I'd have to write my bottom as this. Instead of squared, I'd have to write it sine of x, 3 to the x. And one of those would be gone. So I'd have a sine squared, and I'd have a 3 to the x down there. Okay? Now, again, Yeah, if that one was on there and it was the first one and you were going to earn a 30 out of 30, I would want to see that simplified. Okay, there would be more than one or two of those where you had that kind of a simplifying on it anyway. So if you miss it, you still got your chance to get 80. Okay, but all right, James, that answered. Okay, what else? What else? What else? X cubed, yeah. What do you got? X cubed and then e to the negative x squared. Okay, now I'm probably going to write it like that with parentheses around it, but and I may not. I mean, I typically do, but you just got to understand the negative x squared is the inside of that function. So this is a product rule. So u prime v plus uv prime. So we're going to do 3x squared. We're going to leave e to the negative x squared alone. Plus, we're going to leave x cubed alone. And now we're going to do the v prime. And the v prime is kind of the messy part, right? So what do we got here? I could put parentheses. There's not going to be any plus there, so I don't really need parentheses. I'm just going to do this right here. There won't be any plus signs there. That's when the parentheses are really important. But that's its own derivative. Remember, e raised to the u is its own derivative. It's e to the u times u prime. So e to the negative x squared times negative 2x, right? So really, the only thing I can do, I got this, this, and this. That x and that x have to go together, right? Because that'd make x to the fourth. So this needs to be 3x squared e to the negative x squared. And then minus, I guess, 2x to the fourth e to the negative x squared. And there's no reason to pull out an e to the negative x squared. There's no reason to factor anything out just because there's nothing to cancel it. There's no bottom to cancel it. You could, but it wouldn't need to. Make sense? Okay. Now that's a very, I mean, that's even, that's probably more of a medium one, but I mean that, I don't know. I don't know if that does you any good to kind of get a sense of what you're expecting, but that's it's just kind of a product rule with a little chain rule there, a little bit of simplifying again. Maybe even borderline on a difficult, more hard one. So, okay. Yes.
On the other 196.
Uh-huh.
76.
Oh, don't go that far. Well, we could. Now, okay. Now, here's what I'll ask you, James. On number 76, were you doing the derivative of that? Were you doing, okay, because the directions say antiderivative. But which is fine. Ignore the directions. Ignore the directions. And could I ask you to do a derivative of that one? Yeah, maybe. Maybe. I kind of was saying on to stop at like 59 on this page. So I wouldn't probably do one quite that hard, but I tell you what, let's do one similar. What if I could see asking you this, arc sine, and on the, by the way, on the maze, there was one that was sine -1 or tan -1. I'm going to write it arc tan, right? I'm going to write them all arc tan, arc sine, arc cosine. Okay, sine -1 is the same thing as arc sine, though, and tan -1 is arc tan. But if we had e to the arc sine, and then let's change the bottom to just 1 minus x squared. Let's just change it to that. Okay, and we've been doing a lot of quotient rule ones here, but so something like that wouldn't be helpful. They're probably not going to be much simplifying you can do here, really. So the derivative at the top is just e to the arc sine. It's its own derivative, and then e to the u is e to the u times u prime. What's the derivative of arc sine? 1 over minus x squared. It's just whatever's on the inside of the arc sine. So it'd be that. Okay, and then times the bottom left alone. Oh, that's actually, if I would have left the bottom there, then that would have canceled. That would have actually been nice. But let's just say it didn't. Okay, and so times the bottom left alone minus the top left alone, e to the arc sine x times the derivative of the bottom, which is negative 2x. So actually that one might have worked out pretty good. And then the bottom squared. So you have 1 minus x squared all squared. So actually, technically, you could do something with this right here, because what is this? This would be 1 minus x squared over 1 minus x squared to the 1/2. So you can subtract those powers. One take away 1/2. So this whole thing here could just simplify to 1 minus x squared to the 1/2, because you'd have 1 minus x squared to the first over 1 minus x squared to the 1/2. Subtract those powers. And so those two things could simplify just to that. Otherwise, and then this negative and this negative can make a plus. And then other than that, you really can't do anything.
You expect us to do like that negative and make it a plus?
Yeah, I think so. It's like taking a negative 1 times. If you have to take 2 times 3, that's 6. You have to take negative 1 times negative 2 and make it positive 2. Same thing. Okay? All right, any other? 41, 4 raised to the square root ln x. Sometimes, the ones that don't look bad are just as, have just as much danger in them. Square root of ln x, that'd be ln x to the 1/2 is how I'd write that. Okay? So again, keep in mind that all of this is the inside of that. So the rule of b to the x, of course, is b to the x times ln b, right? b to the x times ln b. So we're just going to do, so y prime is just going to be 4 raised to the ln x to the 1/2. So that's just its own thing. Times, you can put the ln 4 in right away if you want, or put it in later. Okay, and then times the derivative of the inside. So now I'm only looking at the blue thing now, only looking at that. I would bring the 1/2 down in front. I don't really need parentheses here because there's not going to be a plus anywhere. So I'm going to bring the 1/2 down in front. That's ln x to the negative 1/2. And then times the derivative of that inside, which is, now I'm just looking at the ln x. Right, the derivative of the inside there, and that's 1 over x. So, that's it. There isn't anything. I don't think I can put anything together there. And we had that log rule where you could bring the power down in front, but that's when it's inside here. Like if you had ln, if x to the 1/2, if that was the power, you could bring that, but not when it's that. So, other than rearranging some stuff there isn't much I can do with that. Okay, what else? Any issues on the maze? You had to do them all, but what? E and should have had to do them all, but E and Q. E and Q. If you followed the maze, it should have been all of them, but E and Q. Now on E, I would recommend not doing a quotient rule, and same with G. E and G, to me, you just bring the bottom up as a -1 power and then just do it. I mean, you could do a quotient rule, it'd be fine. Then on I would say probably the quotient rule. It seems to simplify easier if you do the quotient rule there. But, and then J is arctan. Just make sure you look at that as arctan. And these were a little simpler. I mean, these were a little more, these would be a little more on the easy than medium probably side, because they didn't have as much stuff as some of this stuff here. But, any other? Well, okay, let's do this. I've got a few here I want to throw up here and let you attempt, see how you can do. And these are a little more challenging, but just they point out some of some things we want to make sure we can do and where I've kind of seen mistakes in the past, so you can kind of see how you're faring, and then you just continue to work on some of those. Don't forget about M1 on the IXL. Nobody asked about any of those. M1 was the implicit differentiation. I'm going to throw one of those up here in a minute. So we're going to have to do that for sure. That's going to be on there once or twice probably. Okay. With the implicit, so we don't want to forget about that. All right. So let's try a few here and see how we do. Okay, here's what I got. Sometimes what people will do wrong here is that LN2, they'll stick it on later, like outside here or something. So again, you've got derivative of the outside, cosine is negative sine. We leave the inside alone. Matter of fact, I was just helping somebody the other day who did this, who had e to the x squared, and they went and did the derivative, and they wrote it as e to the 2x. Okay, never, 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 never change the inside, right? Never, never, never change the inside. We leave the inside alone, and I see that all the time. And so I'll see people do that here, or you'll have x squared plus 3 to the 5th, and you'll bring the 5 down in front, and then you'll put 2x in there to the 4th. You do the derivative of the inside on the inside. We don't do that, right? We tack on the derivative of the inside. So always, always, always leave the inside alone. So anyway, derivative of cosine is negative sine, leave the inside alone, times, now big parentheses, and you guys didn't see me do that, but I put a big parenthesis there because I knew I had a plus sign. So I knew I was going to need to have a big parenthesis there. Those parentheses have to be there. And now when I'm doing this derivative, it's a plus, so I'm doing those individually. So when I do this derivative, I'm doing 2 to the x times ln2. I got to do the ln2 right then when I'm doing the derivative of the 2 to the x. Then the plus, then the derivative of the x squared. Okay? And that's a common mistake I see there as well. Okay, so it's got to look like that. And really, there's nothing, once again, there's nothing I can do. So on this one, we just did it. We were done. On this one, we do it, and we're done. There's nothing else to do there. And remember, this is attached to that sign. It's sign of that. So it's not like we can distribute anything through there. All right? All right. Try that. This one is a challenge. I don't think I would give you one quite this ugly at the end. It kind of gets kind of ugly at the end a little bit. But I thought it'd be a good one to practice and point out several different things that
can occur, they just probably wouldn't all occur in one drop. Just knock this one over.
So I asked her a lot of questions last night.
Totally.
So she
All right. I don't think I finished this, but I did it down to here. Look that over and let me know where you have a question. And I just did this morning, so I might have screwed up somewhere too. It is possible. It has been known to happen.
Can you do the times 6x, like after 5, 3x squared?
Where at now?
35 times 3x.
Yep.
Divided by times
Yep. What did everybody see what he's saying? What did I forget? Right? Oops. Oh. Right here, when I brought the 5 down in front, left that alone, dropped that to a 4 right there, I need a 6x. Derivative of the inside of that, right? Right there. I don't really need the parentheses, but. Okay, yep. Well, I guess the best I can do is 9 out of 10 now. The 6x is the derivative of the inside. So we start, first of all, we're doing u prime v plus uv prime, right? We got a product. So we're doing u prime, we're doing the derivative of that. Well, when we do the derivative of that, bring the 5 down, leave that alone, drop to a 4, do the derivative of the inside. So this is the u prime right here. This is the v left alone. Then this is the u left alone, and then all the rest of this is the v prime, right? Which is this one. So, do the derivative of this, we leave all of this alone, plus we leave that alone, and then we do the derivative of this. So we bring the 2 down in front, we leave all that alone to the first power, and then here we do the derivative of the inside, so the red part then, the derivative of the inside is this. And so that's when I had to worry about this 5x, so I wrote it like this right here. So I bring the 1/2 down, that'd be 3/2, I leave the 5x alone, drop that to a -1/2, then I got to kick out the derivative of the inside, which is a 5, and then plus the derivative of 6x, which is 6. But this 5 has to get kicked out right when I do that, and then plus the 6. Now, what can I put together? Well, right here, let's see, that's all 5th power, so I can't mess with that. This 2, I can multiply with this 3/2, which I can no, I couldn't either. Never mind, because I got this plus. This is all in parentheses. This is all in parentheses right here. Okay? But this 3/2 and this 5 I could put together. That'd be 15/2. So right here I'd have 15/2, 5x to the -1/2 plus 6. So that's what this parenthesis would look like. So I could put that 3/2 with that 5 together. Here I can't really, I could distribute that 2 into there because it's only a first power, but I don't care about distributing, right? Unless it's going to help me cancel something or whatever. But so that, and then where do I got here? This 3, nope, that's inside the squared, so I can't do anything with that 3. That's all inside this squared, so I'm not going to mess with that. But this 6 and this 5, so that could be 30x, and then 3x squared minus 8 to the 4th. And then I'd have this all squared, and then plus, and then I'd have this to the 5th, and then my 2, and then that. So something like that when you roll done. That one's nasty. A lot of little ugly things in there. Okay? All right. Implicit differentiation. Derivative of both sides. You're always going to recognize these, right? They're going to be a mixture of x's and y's. And it's not going to be a y equals like all the rest of the page, the other 8 on the page or whatever. So just do the derivative of both sides. And any time we do the derivative of a y, we tack on a y prime. Then we get the y primes all on one side, and we factor out a y prime, and we divide. Okay, give you a little hint on the, if you want to see this, my first step, you can look up there.
We had minus and then in parentheses 3y plus x y squared, and like we didn't distribute the negative, and we just like left it in parentheses.
You left the minus and you put it in parentheses.
Yeah.
Eventually you distribute the negative.
Yeah, but like we kind of occupied it, and then eventually distributed it.
If you didn't eventually distribute it,
Yeah, just
well,
like.
you have to because you got to group your y primes, don't you?
But like if this is like minus.
No. Your final answer has to be y prime equals. Remember the whole, you got to keep going. You got to gather the y primes to one side. You got to get the non-y primes to the other side. And then you got to factor out a y prime and then divide.
Okay, so you're just.
Yes, you should get on IXL M1 and do some of those if you forgot that. Yeah. Okay, any question on my first step here? Remember the product rule there in the middle? Right? We got to do a product rule right here. So negative 3x, derivative is negative 3. Leave the y cubed alone, so that's where I got that. And then negative 3x, remember attach that negative with that 3 is good practice. Negative 3x left alone, and then derivative of y cubed would be 3y squared, y prime. Normal derivative, tack on a y prime. Plus y, normal derivative would be 1, tack on a y prime, or just common sense, the derivative of y is y prime. I mean, you know, that's the other way to think about it. 1 y prime, or just, but it's not y prime, right? Derivative of y would be 1, tack on a y prime. Derivative of 6x is 6. Okay, now I would never, do not leave the 3 and 3 like that. That makes 9. You need to put those together. I see people do that, and they leave it together like that, like that 3 is supposed to be stuck in the middle between those x's or something. So that makes it 9. So I'm going to get, so this is a negative 9xy squared y prime. I'm going to leave that all. That's one big term. And then this y prime term, leave those there. Then I'm going to move those other two over. Right? A lot of times we have a 0 over here because a lot of times this is just a 6 or something. So a lot of times there's a 0 over here, but not this time. Okay? So I move those over. Now I'm going to take out a y prime. And then I'm going to divide. Right? Implicit differentiation. Probably C1, C1 or 2 or so on are very similar to that. Like I said, you can just make them up all day long. Just throw in some X's, throw in some Y's, put them together so you have a product rule. Probably not going to give you one with a quotient rule or something like that. I mean, that would just, trying to separate out the y primes just gets really messy with something like that. It's probably going to look very similar to something like that. Okay. All right, oops. All right, try it out. Now again, I've already helped you with the part that most people will miss here. Most people will mess up the sine squared. Most people that make a mistake here will mess up the sine squared. They'll put cosine squared. And get all kinds of weird things. Okay, when you see sine squared or tangent squared or something squared, you gotta immediately think of it as that over there. So it's got an inside. Okay? People will think about kicking out the 2, but they'll just treat it weird. So be careful with that. I'm gonna go ahead and uncover it, but don't look if you don't want to yet. If you're not finished. Those blue 2s could go together and to make 4.
You would have to like fall off the X-ray list.
Okay? So the 2, yeah.
Is it not negative x?
What do you mean? Oh, like, would you want me to put the 2 around here with the negative?
Like, would it be negative x? Would you distribute
Would-
the negative?
So would there be a negative here and a negative here? No, because distribute is always over a plus sign. So just, if there was a plus in there, maybe, right? Then that'd be, but it's just times 2. So then it's, and I don't think you need to bring that 2 around over there. Now, if that was a negative 2, and that's a negative, then that needs to multiply to make a positive. That needs to sit down. But the way it is right now, I can just leave. But the 2 2s there are 4. So remember, the quotient rule, we got this batch, and then this batch, and then in here we can multiply it together. So 2 and 2. Now, this is another one of those that if it would have been flipped, if it had been this same problem flipped, okay, then it would have looked like this that I have down here in the red. Okay? Well, now you could do a little bit more because you have this part here, and then you have all of this here. Well, clearly the 2 and the 2, again, can make a 4, but what do you have that could cancel? One of the signs, right? You could pull a 6. So this is one batch, this is one big set of term, or one term and another big term, or a set of factors, you might say, or a product. And this is another product. And we can take out, each of those has a sign in it. So you can take out a sign, 2x, cancel with one of these. So this would just be 1, there wouldn't be any sign here at all. And then this would change to a 3, right? Because you could cancel, so you could pull out a sign, and then you could cancel it with one of the signs down here. And then the 2 and the 2 could go together and make 4. So, right? So if that would have been, so if this would have been flipped, it would have, that could have happened. But as it was, the only thing we could do is the 2 and the 2. Okay, I think that's it. Okay, that's all I really have. I just thought that was kind of those are some things I can think of that cross people up. The other thing, of course, is your derivative rule sheet. We haven't really, at least we haven't up here as a class done any what's the derivative cosecant without looking? Cosecant. Negative cosecant times cotangent. So kind of goes like this. Derivative of tangent is secant squared. They kind of go in pairs, right? So derivative of tangent is secant squared. Cotangent is negative cosecant squared, right? So it's very simple. Secant, the derivative is secant times tangent. So secant, the derivative is secant times tangent. Cosecant is negative cosecant times cotangent, right? The co-functions kind of go together. And all the co-functions are negative, aren't they? Derivative of sine is cosine, but derivative of cosine, those are called co-functions for a reason. Cosine, cosecant, cotangent. Cosine is negative sine.
The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. Okay? But anyway, so memorizing those, arc sine, arc cosine, arc tangent, and really the rest of them, log we've used quite a bit, the other exponential we've used quite a bit, power rule, Chan, and that's it. That's the thing, right? Those are the rules and how we put them together. Okay, so I'm going to let you work here. Again, I don't think you can do too many of these. M1 IXL has those. Other IXLs, you can grab some here and there. Just keep doing ones on page 195. About the time you feel comfortable with them is when you're probably good for 6 out of 10 on the gateway. You really should be over comfortable. You should be to the point where you feel like you could get, 10 out of 10 every time. And that's probably a 9 out of 10, maybe an 8 out of 10, because you're going to do something silly. At least on one problem, you're going to forget something, probably. And then you're going to come across one that you're just going to forget. You're going to be like, oh, crap, I forgot to review that rule, or whatever. And then we move on, and then you got to keep up with the new stuff and practice and find time to retake too. So. There's still those websites as options too.